So this is going to be a short tutorial that is a review and an application. So we've learned already the three trig ratios, right? So we have our sine is opposite over hypotenuse, our cosine is adjacent over hypotenuse, and our tangent is opposite over adjacent. And we've learned our reciprocal functions, and that is cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. So we have these 6 ratios. And these have to all do with the sides of a right triangle. Okay? In relationship to its angle, to their angle. So if I draw a right triangle, I can use these functions in many, many ways. If I decide to mark this as theta, I can just pick any numbers that I want right now. So let's pick 7 and 16. Okay? If I pick 7 and 16, I just picked these random numbers. I can use these numbers to find out what theta is. And I can also use these numbers to find out what the missing side is. So there are a couple of ways that we can do that, but this way is going back to the good old 8th grade when we did the Pythagorean theorem. So how are we going to get this missing side? We're going to write, I'm going to call this x for now. So x squared plus 7 squared equals 16 squared. X squared plus 49 equals 256. Subtract 49 on both sides. So we have x squared equals 207. And then, excuse me while I get my calculator. And then we want to get a square root. But you know what? We don't even really need to get a decimal here. We can just say that x equals the square root of 207. We're just allowed to do that. So let's just leave it as the square root of 207. And just for fun, we can put that in our calculator so we have an idea of what the square root of 207 is. So I'm just going to put that over here. The square root of 207 equals 14 point, if I round to the nearest hundredth, 39. Okay, but we can still use this one here. So when I put this in, I'll take this and I'll put a different color in. I can now write all of my functions according to what I have here. So the sine of theta is going to be 7 over 16. The cosine of theta is going to be the square root of 207 over 16. The tangent of theta is going to equal 7 over the square root of 207. And then I can do my reciprocals, but I'm going to leave a space for a very specific reason. If I do my reciprocals, I know that the cosecant of theta is now 16 over 7, because I know that it's the reciprocal function to sine. I also know that my secant of theta is 16 over root 207. And I'm hoping that you're saying, well, you really can't divide by a root. But when we have our trusty calculator, we can. So we don't have to rationalize this denominator. We're just going to leave it like that. And then I know that the cotangent of theta is equal to 207, the square root of 207 over 7. So, well, what do we do when we get these numbers? These numbers are just, they're rational numbers, or actually irrational numbers in this case, but they're numbers that we can transform into decimals. So I'm simply going to put 7 divided by 16 in my calculator, and I'm going to get 0.4375. You see that? 0.4375. So this is an actual decimal. This is a decimal here. Can I make this decimal into a fraction? I absolutely can. I'm going to just try to focus this in a little bit better. Okay? I can make this into a fraction by simply putting it over 1. I'm allowed to do that. I'm allowed to have decimals in fractions. I'm allowed to have square roots in fractions, because now we're going to be manipulating these things. Okay? So now the question is why am I even telling you this? Why am I saying, well, if I put this into a decimal, and then rewrite it as a fraction, what information is that going to give me? Well, that's going to give me a way to figure out the cosecant when I'm given a sign. Because our calculator, as you know, only has sine, cosine, and tangent. It doesn't have cosecant, secant, and cotangent. So how can we use our calculator to get these numbers if it's not so beautiful here? Well, let's think about it. What is 16 divided by 7? If I put that in a decimal, I get 2.2857. We always want to go to 4 digits just because that's going to be the most accurate. Okay? Now, how is the sine connected to the cosecant? Well, we know that the cosecant is the reciprocal of the sine. So in my calculator, I want to take this and do this work and make it a reciprocal. So what is the reciprocal of 0.4375 over 1? It's actually 1 over 0.4375. So if I do this in my calculator, and I'm going to ask you to pause and do this in your calculator right now. So pause it and then come back. So if you come back, 1 divided by 0.4375 is, well, what do you know? It's exactly this number. So this idea is going to help us find cosecant, secant, and cotangent on our calculator. And the same thing goes for all the others. So I'm going to quickly just do this math. The square root of 207, close my square root off, divided by 16, and I get 0.8992 if I round. Keep that in red. I put that over 1, and then I do the reciprocal in my calculator. 1 divided by 0.8992. I bet you any money when I put that in, they're going to be the same thing. Well, let's see. So there's 1.1221, because if I round the 9 up, okay, I'm going to make the 0 round up. So now, because I can, I'm going to put this in my calculator. And there you go. So this is actually 1.1121. Now you're wondering, why are these so different? Like, why is this a 7 and this a 9 and this a 6 and this a 9? Well, because what we did here is we rounded this one here. So this value has all of these behind it that we just kind of threw away. So it's going to differ a little bit a little later on, but you'll notice that's why we go to 4 digits, because if we go to 4 digits, we get the exact same answer. Okay? So, what does this have to do with the work that we did in class? Whoops. Okay. So I'm going to show you what we did in class, and then I'm going to ask you, well, I already asked you, and again, I don't know if this is very focused, so I'm going to try that again. Okay. I asked you to find the cosecant of theta. Well, we know that the cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, the cosecant is going to be hypotenuse over opposite. Well, here's the opposite, right? So I don't know the opposite, so I'm going to have to find the opposite. So I'm first going to have to use the Pythagorean theorem. 3 root 5 squared plus x squared, because that's my x over there, equals 9 squared. Now what is 3 root 5 squared? You can either do that in your calculator or you can think about it in your head. 3 root 5 squared is 3 squared and root 5 squared. So 3 squared is 9. Root 5 squared is 5, because anything under the radicand is the answer when you square a square root. So 9 times 5 is 45, plus x squared equals 81. So x squared equals 81 minus 45, and that's going to give me 36, and oh, isn't that lovely? So if x squared is 36, x is 6. So I can put a 6 there. And now I can figure out my cosecant, because now my cosecant is the hypotenuse over the opposite. And so that's the answer to number 3 that you had to do for homework. So I want you to look at that and then try to do 4, 5, and 6. Once you've done 4, 5, and 6, you can unpause this and we're going to move on. So now that we're moving on, we're going to say, how do we find the cotangent theta if cosine theta equals 3 over 13? Well, what does that mean? Because they're not giving you a picture. Your job is to actually make the picture. So what does the picture look like when cosine theta equals 3 over 13? Well, we know that the cosine is the adjacent over the hypotenuse. Agreed? So I'm going to go in here and I'm just going to draw a right triangle. I'm going to put my theta really anywhere I want, but I know that you guys like it in this kind of base angle, so I'm going to put it there. The adjacent leg is 3, and the hypotenuse is 13. So if I know that the adjacent leg is 3 and the hypotenuse is 13, again, I can use the Pythagorean theorem to find this missing side. So I'm just going to go over here on my paper because I don't have really, I can do it here. I'm going to do it in blue. So again, this missing side, I'm going to call it x squared plus 3 squared equals 13 squared. That's our Pythagorean theorem. So x squared plus 9 equals 169. So x squared equals 160, and x equals the square root of 160. And that's what I'm going to write in there. I'm going to write that into my missing number, the square root of 160. So now, can I find the cotangent of theta? Well, so the first thing I have to do is say to myself, and I'm going to put a piece of paper here so I can do some work here. So the first thing I'm going to do is I'm going to say to myself, well, what is what is tangent? Tangent is the opposite over the adjacent. So now do I have the opposite here? I do. The opposite is 160, the square root of 160 that is, over the adjacent, over 3. So what is the cotangent? The cotangent of theta is going to be 3 over root 160. And when I put that into my calculator, and that's what you want to do because you want a decimal, 3 over root 160 equals 0.2372. 0.2372, because we want to round to 4 decimal places. So the cotangent of theta equals 0.2372. 2372. And that's the answer to number 7. So again, I want you to pause and I want you to try number 8. Number 8 says the cosine of theta, find the cosine of theta if the sine of theta equals 4 root 13 over 17. So pause, draw your picture, solve for your Pythagorean theorem, and then give me the cosine of theta. Once you've done it, then you can unpause it and watch me do the solution. So here we go. Here's the solution. So again, find cosine theta if sine theta equals 4 root 13 over 17. What am I going to do here? I'm going to draw my picture. It doesn't really matter what kind of right triangle I draw. Okay? If I have theta here, opposite, remember sine is opposite over hypotenuse. So the sine is opposite, so my opposite leg is 4 root 13, and my hypotenuse is 17. And now I go and I do my Pythagorean theorem. 4 root 13 squared plus x squared equals 17 squared. So 4 root 13 squared is 16 times 13. And 16 times 13 is 208. So 208 plus x squared equals 289. We know that because we know our square numbers. I subtract 208 on both sides, and I get x squared equals 81. Oh, isn't that beautiful? So if x squared equals 81, x equals the square root of 81, which equals 9. And now I know my adjacent leg, and I'm going to put that in red so you can really see it. And so now I can do my cosine. So cosine theta equals 9 over 17. I put 9 over 17 into my calculator, and I get 0.5294 because that 1 doesn't affect the 4. So cosine theta equals 0.5294, and that's the answer to that guy. Okay? So I'm going to give you a couple just to try on your own. So your final homework is going to be to finish up 3, 4, 5, and 6 if you haven't already, and then I want you to try these. So I'm going to write these down. I want you to try them, and I want you to show me that you tried them. Of course, you're going to pause it so you can write them down, and then you'll be done. So the first one I want you to try is find the tangent of theta if the sine of theta equals 5/8. That's the first one I want you to do. The second one I want you to do is find cotangent theta if the cosecant of theta equals 3 over 2. And last but not least, I want you to try this one. Find the secant of theta if the cosine of theta equals root 2 over 10. So that's your job, to not only do those 4 on the worksheet, which are given to you with diagrams, but make your own diagrams of these guys, and then get your decimal. Have fun!